Hello students, let me start the class now. In our previous class, I had discussed some basics about what is information. So today exactly we will start with the syllabus because we had only a general discussion in the earlier class. What is information? Please recall, information is that which is unknown. When it becomes known, it becomes knowledge, and when it gets retained, that becomes memory. Why we study information theory? Because we are going to transmit information in all types of our communication channels, such as either audio channel or video channel or radio channel. Everywhere, we are actually going to use these communication channels for the transmission of information. So that is why information theory, even though information is in general a philosophical term, information theory is basically a technical term or a scientific term. All the classes I am going to record, and the recordings I am going to put it in my YouTube channel. Those details I will share later on in the Google class. So in between, if you have any connectivity issues or if you have any audibility issues, you can always go through the recorded videos of each class. Okay. So let us start. The earliest methods of communication used to be speech, gestures, and pictures. You can see here speech, gestures, and pictures. In general, we speak with each other, or we will have a visual hand gestures or sometimes facial gestures. Smile itself is one facial gesture, or else we communicate through pictures. That used to be the method of communication, and that was for a short distance. And for a longer distance, in the olden days, they used to use smoke, and they used to use pigeons, and they used to use pigeons for carrying letters. You remember that song in that Maine Pyar Kiya movie, very hit movie, where Kabutar Ja Ja song is there. So, olden days, pigeons were trained to fly to a particular destination itself, and to the pigeons, these letters were tied to their legs, and either letters through post offices was delivered, or else in the olden days they used to simply put a smoke on a hilltop, and neighboring villages used to see the smoke and they used to understand that something dangerous is there. This is in the very olden days. The modern methods of communication are using now electrical signals, and it can be wired or wireless. Electrical signals, nowadays we are using optical signals. For example, the whole earth is now connected through a optical fiber backbone network. Below the Atlantic Ocean, below the Indian Ocean, below the Pacific Ocean, there are very thick cables laid, and all these cables are basically working through the optical communication. That is how nowadays, if you make a call to USA from India, or if you receive a call from USA to India, you don't find any delay in the speech. There is no latency because the call is not going through satellites. It is now going through optical fibers in the speed of light. So the modern methods of communication, along with electrical signals, it is optical signals as well. But at our end, it is always electrical signal. And it can be wired or wireless. Right now, the communication between you and me is wireless because I am using a Wi-Fi channel in my laptop. But the Wi-Fi is again connected to a backbone network that is again wired. That wired channel can be electrical channel or it can be an optical channel. For example, from the base station till the main switching center, it can be a electrical wired channel. Later on, it can be a optical wired channel. Not audible, but I have unmuted and I am recording this. So if there are network issues, bear with this. Maybe after some time I will become audible. I am seeing my waveform here, and whenever I speak, I am seeing this waveform. Okay, I am anyhow unmuted here. Anyway, go through the recording later on. It can be wired or wireless. Again, the message is coming, we can't hear you. Hello, hello. Am I audible now? Okay, let me do one thing. Let me turn on the hotspot. Hello, hello. Hello. I hope I am audible now. I have connected through a hotspot network. Am I audible now? Yeah. Now I am audible. I am able to see the waves there. Okay. Anyway, whatever you have missed, recording I will be posting in the Google class. My YouTube channel's link I am going to post. Later on, you can go through the recordings. So let me continue. This is the general block diagram of our communication network. This is a general block diagram. You can see this general block diagram. We will have an information source and we are going to transmit it. Then we have a medium. That medium itself is a communication channel which can be wired or wireless. And then at the receiving end, there will be a receiver equipment. Then there will be an output transducer. So this is the general block diagram of a communication channel. Now this channel is going to introduce a noise and the channel is going to introduce interference. The channel is going to introduce distortion. The channel is going to introduce attenuation and the channel has bandwidth limitation. Noises are of many type. This noise, there's an exclusive chapter in analog communication for you where you will study more about the types of noise. So this channel, whether it's a wired channel or a wireless channel, it is going to introduce noise. And if it is a wireless channel, there are other radio waves also used as carriers. And there will be interference between the multiple radio waves which are used as carriers. That is called interference. In the wired channel, such interference is very less. But in a wireless channel, there is more and more of interference. And there is distortion. Distortion in the sense, this channel will have its own non-linear characteristics, whether it is air medium or whether it is space or whether it is optical fiber or whether it is electrical wires. All these channels will have their own non-ideal characteristics, which means, let us say we have a twisted pair wire. A twisted pair wire cannot handle frequencies which are beyond kilohertz. Whereas a coaxial cable can handle the frequencies which are beyond kilohertz in the range of megahertz and even gigahertz. Whereas space can handle all types of frequencies. Optical fiber can handle the frequencies in gigahertz. There are enough network issues. What to do?
Should be not audible, sir.
Yeah, there are network issues. I am speaking once again. Now I am audible. So let me go on. Shortly we will be having a LAN connection. Our laptop, we will be connecting it to regular LAN, and I think at that time at least these problems will be solved. Within 1 or 2 days we will have the solution now. So let me come back. There is a noise, there is an interference, and I am discussing about distortion now. Distortion in the sense the waveform's shape will change. The input wave shape and the output wave shape will not be the same. That is called as distortion. For example, you have already studied about clippers. All the clippers introduce a waveform distortion. So when the signal goes through a channel, and because of the non-ideal nature of the channel, each channel will have its own non-ideal characteristics, due to which the waveform will get distorted, wave shape will not remain the same. Which means if a Lata Mangeshkar's song is transmitted, at the other end Usha Uttup's voice may be heard. Now that is called distortion. Interference is different. Interference means one wave interfering with the other wave, or one signal interfering with the other signal. Noise is something different, which the channel itself is going to introduce, especially electrical noises in case of electrical cables, switching noises, or in the air medium there can be electromagnetic noises, and even the space will have electromagnetic disturbances or noises. Now coming to attenuation. What is attenuation? Any channel will have its own resistance. Even the optical fiber cable will have its own loss of light when the light is passing through the optical fiber. So the reduction in the intensity of the signal, that is called attenuation. And there is a bandwidth limitation. I gave an example of twisted copper wire, and then a coaxial cable, then optical fiber. I have listed them here. Copper wire has a serious bandwidth limitation. It cannot handle signals which are beyond kilohertz, the normal copper wire. Because when two wires, let us say the main wire and the ground wire, when they are together, when they are adjacent to each other, the insulation in between the copper wires itself is going to act like a dielectric medium, and this general wire, which is simply a two wires together as a pair, that will act like a capacitance throughout its length. And wherever there is a capacitance, there is a loss of AC signal. That means the AC signal gets coupled to ground. So the regular copper wire will have this capacitive effect. Just to reduce this capacitive effect, what they do is they twist this wire among each other. So that is called as a twisted pair. When it is twisted among each other, the capacitive effect gets slightly reduced, because it is not like a parallel wire now. It will be twisted wire. If it is a parallel wire, throughout the length of the wire, there will be a capacitive effect. This twisting is going to slightly reduce the capacitive effect. So many times in the landline telephone network, they used to use twisted pair wires. And for handling megahertz and gigahertz, they will have coaxial cable. Means at the center you will have a conducting wire, and around you will have a shield. That shield itself is like a ground wire, and there will be a thick insulation in between, because around the conducting wire, as it is a shield, it is not another wire there. So the capacity effect is further reduced. The ground wire is like a distributed mesh. It is not like a single wire. So the capacity effect of the coaxial cable is further reduced, and it can handle megahertz and gigahertz. That is when it is also called as cable TV network, where this coaxial cable is used for connecting the video medium or the cable network to the television. Lastly, the optical fiber is having the highest amount of bandwidth, because we are using light as a carrier here. We are not using radio waves as a carrier. As you already know, 20 to 20 kilohertz is audio signal. Above 20 kilohertz is radio signal. Sometimes 20 kilohertz to around 100 kilohertz, around 300 kilohertz, or even up to 300 megahertz. In general, they call it as sometimes they call it as ultrasound, and they call it as radio wave. Beyond 300 megahertz, they generally call it as microwaves. So we cannot have a sense for radio waves, but we can sense light, we can sense sound. In between radio wave, we cannot sense. That is why the radio wave is used as a carrier wave. But even the radio wave, let us say from 300 megahertz till about 300 gigahertz, we can keep using it. Beyond which, that is coming under the infrared band, and then later on it is red light till violet light. It's a visible light. So light is in the frequency of terahertz, so even light can be used as a communication channel. So that way, this is all wired channel. Now if I have to talk about wireless channel, we are using space itself as our medium, and space around us is filled with air, beyond which there is no air. For example, we divide this sphere into atmosphere, then stratosphere, then troposphere, then ionosphere, then exosphere. In general, above 5 to 6 kilometers of Earth, there will be no air. There will be no air. It will be totally vacuum. In general, international flights, when they fly up, they will have to take care above certain kilometers, there is no air medium at all. It will be vacuum there. And there are something called air pockets in this air medium as well. In somewhere there air will not be there, somewhere air will be there. So suddenly flight which is going up, if it finds an air gap there, suddenly the flight will come down there. This is happening in the international flights, but in the local flights, those aeroplanes do not fly that high. So such experience is not there with those passengers. Why I told this example is, beyond 5 to 6 kilometers, there is no air there, but space is there. Space is vacuum there. So in the vacuum medium also, electromagnetic wave can travel. So in such case, we can use the complete space as wireless medium or electromagnetic medium. Don't call it as air medium, because air is not the channel here. Air is present in space around us, that's all. Otherwise, we are not using air as a channel here. We are using space itself as a channel here. Air is a channel in between you and me only when we are physically speaking to each other. For example, speech from my throat will come out and it will hit your tympanic membrane in the ear when you are physically in front of me. At that time, in between you and me, there are a lot of air molecules which are colliding with each other, because my speech is around 300 to 3400 hertz. Normal speech bandwidth is around 4 kilohertz. That is going to make the air molecules to vibrate and hit each other, and that vibration is gradually transmitted to your ear. Inside your ear canal, you will have a tympanic membrane, and the membrane vibrates, then you hear me. So if you are in front of me physically, then we are using this air as a medium. That is actually air molecules only are colliding with each other. But when we are not physically present right now, we are using the space as the medium. In the space is filled with the gravitational force, and the gravitational force is nothing but part of magnetic force. And we are using antennae to radiate the signal into space, which means it's an electromagnetic spectrum there. We are using electromagnetic waves as the carrier waves for communication purpose. So the channel can be wired channel or wireless channel, and the types of information can be voice, sound, music, picture, video. See, first we have voice. Now right now my voice is around 300 to 600 hertz. In general, male voice is 300 to 600 hertz. Female voice is 600 to 900 hertz. Males undergo puberty, and when they undergo puberty after adolescence, the male vocal cords become thicker. So whenever any object is thicker, the vibration rate is lesser. For example, you visualize a guitar. we have a bass guitar also, or bass guitar. In that guitar, the string is thick. When the string is thick, it is going to produce a sound which is much lesser in frequency. Whereas if the guitar is having a very thin string is going to vibrate for a larger number, and then it is going to produce a higher frequency. That is how male vocal cord is thicker, female vocal cord is thinner. That is why the male frequency is around 300 to 600 and the female frequency is around 600 to 900. Whereas children's frequency is beyond 900 to around 1200 hertz, because children's vocal cord is still thinner. But along with our normal fundamental frequency, we will have harmonics. So, in general, they divide the voice frequency as a range between 300 to 3400 hertz. And that is when we, in general, say that the voice bandwidth is 4 kilohertz. So, you are already familiar with the Nyquist sampling rate. Voice bandwidth is 4 kilohertz, sampling rate is into 2, so sampling rate is 8 kilohertz. 8 kilohertz, each sample is quantized into 8 bits. So 8 bits is one sample, 8 kilohertz, 8 into 8 is 64. So the general voice data rate is 64 kilobits per second in the telecom networks. This we will be studying more about this particular concept in the digital signal processing course as well. So students, remember this particular data rate, 64 kilobits per second is equal to 8 bits into 8 kilohertz, or it is 8 bits into 4 kilohertz into 2. 4 kilohertz is the voice bandwidth. It is sampled twice. It is 8 kilohertz and each sample is quantized into 8 bits. Then it is encoded. After the quantized sample is encoded into 8 bits. That is the process of sampling, quantizing and encoding, and the result is 64 kbps. Okay, that is about voice. Voice is about 300 to 3400 hertz. What is sound then? What is sound? Sound is generally 20 to 20 kilohertz. All audible frequency range is called as sound. Now you have 20 hertz, then you have 300 hertz, then you have 3400 hertz, then you have 20,000 hertz. Just visualize this line: 20, 300, 3400 and 20 kilohertz. Now in between 300, 3400, that is called voice. Total 20 to 20 kilohertz is called as sound. Now what is that which is in between 20 and 300? That is called as bass or bass, B-A-S-S. That is why I mentioned that bass guitar. That is going to produce a sound which is between 20 hertz to 300 hertz. Now after 3400 hertz till 20 kilohertz, there is also frequency range. What is that called? That is called treble. So initially there is bass or bass, then there is voice, then there is treble. Together this is going to become a music. So that is what is music. Music is the sound which we listen and which we enjoy. So in the music you will have a singer who is giving a sound or voice which is vocal. Along with that you will have a person who is beating drums, or person who is playing tabla, or person who is playing mridangam. Now these instruments are going to produce lower level of frequencies, lower side of frequencies, that is bass frequencies or bass frequencies. Along with that you will have somebody who is playing violin or guitar or sitar or veena or flute. All these are going to produce a frequency which is more than 3400 hertz. That is called treble. So the instruments such as tabla or mridangam or ghatam also, or drums also, they are all called percussion instruments. Means when we beat a surface, when we beat a leather piece which is tied around a wooden piece or a metal piece or whatever, Now that is called as a percussion instrument. Now whatever is the instrument which is stringed, like violin or sitar or guitar or veena, they are all stringed instruments. Now flute is a resonant instrument. Flute or nadaswaram, nagaswaram also they call, that is called resonant instrument, where the air column is resonating inside a cavity. So when we use all such sounds along with the singer, then it is music. There can be music without the singer also. Only instrumental music is also possible. So that is all music. Now we use voice, sound and music as information. Then we use a picture as an information. We use video as an information. Picture. In the Bengaluru city, when you travel through car or a bike or a bus, you will see so many traffic symbols there. No parking is one particular symbol. If there's a hump there, there will be a symbol at the roadside. Speed limit, there will be a symbol. And all those, let us say a bridge is there. For a bridge also there will be a symbol. For a diversion also there will be a symbol. All these are pictures there. Wherever there are high voltage electrical transformers, you will see one skull symbol along with two bones. That itself is a great symbol. Even an uneducated person can understand that symbol. That if he touches that, he will become a skull and a skeleton. Any uneducated or illiterate person also, when he looks at the symbol, he may not be able to read the word danger there. D-A-N-G-E-R. Let us say he is illiterate, person who does not know how to read English also, he will be able to understand the symbol of a skull and two bones. He will come to know that if he touches that transformer, he will become that symbol. So that way, we use the pictures as communication medium effectively. Then anyhow, we are going to use video as information. So all these are analog. Now what are digital? Digital are the ones where we use text. When you type an SMS in the mobile, you are going to type in English language. Now each character in the English language will have a code called ASCII code, American Standard Code for Information Interchange. That particular ASCII code. Nowadays we have Unicode also in the communication field. So this ASCII code is allocated to each and every character which you type. For A it is a different code, for B it is a different code, for C it is a different code. Even for punctuation marks and all other grammatical symbols, there are ASCII codes. Even for graphical symbols, there are ASCII codes. So this ASCII code is the encoded binary version of a text. That is how when you type an SMS or when you type an email, basically that is going as binary digits. That is when we call it as a data. Text can be converted into data, voice can be converted into data, sound can be converted into data by means of sampling, quantizing and encoding. Music can be converted to data. Picture can be converted into data by means of scanning it. It is called as a raster, where left to right, horizontal scanning, again come back, again one more scan, again come back. That way, the complete picture can be converted into pixels. Each picture element is called as a pixel, and the picture can be completely converted into so many pixels. And all these pixels can be stored inside memory. And when it is converted inside memory, it is a data, and that data can be transmitted. Even a monochrome black and white picture can be converted into pixels. Even a color picture also can be converted into pixels by means of the fundamental colors. Generally they use RGB, red, green, blue. Using these three, they will have brightness, contrast measurements, and they will have binary information for even other compound colors. That way picture bank can be converted into data by means of scanning, and video also is converted into data. Video is converted to data in the sense that video is again sampled picture by picture. In fact, when you see a movie in a film theater, in the olden days there used to be an analog reel, film reel. That reel used to roll in front of a light, and each that reel used to have so many small frames, and the frames were moving in a faster speed. When the frames are moving in a faster speed, human eye has got something called as persistence of vision. Our eyes are slower. So when we have this persistence of vision, and if something is moving beyond that persistence of vision, we see as if it is a moving picture or a motion picture. That's why it is called as a motion picture. Otherwise, it is a single picture. That is how video is basically a sample of so many pictures. Again, a picture can be again scanned and converted into data. Nowadays, in all movie theaters, we have digital projection, where complete data is going to be projected that way. We have ADCs and DACs everywhere now. Analog to digital converters and digital analog converters are present in each and every communication equipment nowadays, and even in projection equipments nowadays. Almost in every electronic system, we have ADCs and DACs. So I told you briefly about what is the type of information. It can be voice, sound, music, picture, video, which is analog. Analog means it's a continuously changing type of information. Whereas text and data is a digital type of information. Anything that is binary is having only zeros and ones, and that is a digital type of information. So what is the goal of the communication system now? The goal of the modern communication system is to convey more and transmit less. Please remember this particular sentence. The goal of the modern communication system is to convey more and transmit less. Means what? We have bandwidth limitations in each channels. For example, we have a wired channel, we have a wireless channel. We have something called multiplexing, where we want to use the same channel for transmitting many carrier waves. In such a case, that is called multiplexing. There are many methods of multiplexing, such as time division multiplexing, frequency division multiplexing, space division multiplexing, and so on. You are going to study about them in your future courses. So, when we want to use a single channel for multiplexing lot of other signals, now that is called transmitting less. But we have to convey more, means the information should be conveyed more, but the transmission must be lesser. You students are experts in typing such SMS messages. In general, people like me who belong to older generation, if at all we have to type on SMS, we simply write how are you, and we put a question mark, and we put space also in between. Now HOW space ARE space YOU and question mark. It became how many characters now? 4 plus 4 plus 4. It became 12 characters. 12 characters into 8 bits. It became totally 96 bits. Now, this is what is going to be done with you now. When you type the same SMS, you simply put HRU. You will not put a question mark also. Instead of how are you with spaces, you will simply put HRU without space, which means the same. How are you only. People should understand that it is how are you only. So there it is only 3 characters into 8 bits. It is totally only 24 bits, whereas in my case it was 96 bits. That way, transmitting is less, conveying is more. Information is conveyed, but the transmission data is reduced. So the goal of the modern communication system is that we should convey more. That means information should not be lost in any way. Complete information should be conveyed, but it has to be conveyed with the lesser number of bits or lesser number of resources, so that we can save the amount of resources and we can reduce the cost of this communication. That is the goal of the modern communication system, and we are achieving it actually. We are achieving it by means of many methodologies, which you are going to explore one by one in this course also and in other courses also. So, the people-to-people communication is essentially analog, whereas people-to-machine and machine-to-machine communication is essentially digital. Because nowadays all machines are digital. Whenever I say machine, we are referring to electronic machine. We are not referring to a mechanical machine. Now, in front of me there is this laptop. This laptop is basically an electronic machine. What is basically a machine? Machine is something which is going to reduce the human effort, and it is going to increase the efficiency of a work. So this laptop is going to reduce the human effort, where we can store a lot of things through this laptop. Whereas the machine is going to increase the efficiency of the particular work. Means machine is much faster than a human being that way. So all these electronic machines, when we have machine to machine communication or when you have people to machine communication, it is essentially digital. Every system, electronic system, is having a microprocessor or a microcontroller along with the memory, along with the ADCs, along with the DACs, along with the communication ports and different types of signaling methodologies, communication protocols, and wired medium or wireless medium. Lot of things are there in this particular communication system now. So only people to people communication is essentially analog, where we are using variable waveforms or variable signals of voice or sound, whereas all other communication channels are or communication methodologies are basically digital. In addition, the information source can be analog and discrete. I'll give an example. Microphone and video camera are analog sources, whereas teletypewriter or computer are discrete sources. What do you mean by discrete? When I type a key in the laptop, I am not going to type continuously. I am going to press one key, later on another key, later on another key. Now this is not a continuous type of information. This is a discrete type of information. That is, a computer is a provider of discrete type of information. We can say it's a discrete source. Similarly, teletypewriter. Olden days they used to send telegrams using a typewriter. And in the typewriter, they used to type again just like we are using our laptop or desktop. Actually, from the typewriter only the same keyboard is utilized nowadays in laptops and desktops as well. And they had worked a lot about designing this particular type of keyboard. You can think why there should be QWERT, POIUY this way, why there should be ASDFG and LKJ this way. You may think, but they had done a lot of research about how these 26 alphabets have to be arranged and which are the alphabets which are mostly used, which are less used, how it is easy to type. That way, people had designed this particular keyboard in this fashion only. And you can actually see on key F and on key J, you can find a small indentation. On this key F and key J, you can always find a small indentation. The purpose is even the blind people can find out where exactly is F and J. Automatically, when they keep the forefinger on F and J, they can immediately visualize all other alphabets which are around it. And even blind people can type, but with practice. They also have to practice typing through the same keyboard. That is how typewriter itself became keyboard in laptop or in desktop. So olden days they used to use a telegram system. Nowadays same telegram system has come in mobile also as an app now. Along with the WhatsApp, we have a telegram app as well. But olden days they used to have a teletypewriter, where in the typewriter they used to type and it used to go over copper wires as a telegram message. And the other side they used to receive and they used to print it, or somebody used to find out this Morse code and they had to be an expert in Morse code, and they used to physically write the message in accordance with the Morse code. Now anyhow, all of that has become obsolete. Once mobile phone came into picture, all these have become obsolete. But the example of this teletypewriter is, the output of the teletypewriter is discrete, because it is one letter afterwards one more letter, whereas microphone and video camera is analog. So information can be analog also, information can be discrete also, both can be converted into digital. Now analog information becomes discrete after sampling and quantizing. Just visualize a waveform, sine waveform. The sine wave you will sample at two places. So visualize an impulse there. You have already studied signals and systems. So you recall that sampling method, where a sine wave will have two samples in a cycle, and those two samples are right now with an impulse when they are sampled. It is actually only two samples per cycle, and that sample is discrete now. And each sample will have a certain amplitude, and after that it is going to be quantized. After quantization, let us say for 0.2 volts, 0.4 volts, 0.6 volts, 0.8 volts, 1 volt, there can be different steps for quantization. And for each quantization level, there can be a binary stream allocated or a binary set allocated. That is when it becomes completely digital. After encoding, it becomes digital. Otherwise, after only sampling and quantizing, it is simply discrete pulses with varying amplitudes. So, analog information becomes discrete after sampling and quantizing. Now, a discrete information source consists of a discrete set of letters emitted as symbols. Now, in our course, we keep on using this particular word called symbols. The meeting is going to end in another 5 minutes. Anyhow, I am going to put this recorded class into YouTube channel. That link I am going to share with you. You subscribe to that YouTube channel and you can keep on watching the class videos even if you miss out. Okay, we keep on using symbols. That is where I'll stop this class now. I'll discuss about the symbol now. What is the meaning of symbol? Let us see. In general, what is the meaning of symbol? We will have many symbols which we use in our life. A symbol is a small representation of some other bigger information. Same way, here in our course, Information Theory and Coding, we will not say always letters or we will not say always alphabets. For example, in a telegram, it is not letters or alphabets. It's a set of codes which contain dashes and dots. The combination of dash and dot. Now, a particular combination of dash can be a symbol. A particular combination of dash and dot can be a symbol. For example, 3 dots can be one symbol. 3 dashes can be one symbol. 2 dashes and 1 dot can be one symbol. 1 dot in between 2 dashes can also be a symbol. That is why you understand a symbol can be a set of characters and a character can be a set of bits. You remember this way. A discrete information source consists of a discrete set of letters emitted as symbols. For example, the source alphabet for a teletypewriter can be 32 letters, 26 English letters plus 6 special characters. These characters are called as symbols and they are transmitted as bits. For example, A is 97 decimal, whereas capital A is 65 decimal. Hence, the message can be defined as a sequence of symbols, and the symbols comprise of binary digits. Symbols are discrete. For example, let us say I say hello. When I say hello, H-E-L-L-O, that hello is a message. That hello itself contains H-E-L-L-O. Now, H is a symbol, E is a symbol, L is a symbol, L is a symbol, O is a symbol. If H is capital, then its decimal form is different. If H is small, its decimal form is different. Now, you may ask me a question, why can't we call it simply as alphabets? No, alphabets means what? Alpha means alpha, beta, gamma, delta, theta, iota, kappa, like that it goes on. Zeta, like that it goes on. Alphabet generally refers to a Greek set of those letters, alpha till omega, something like that. Okay, in English we have A till Z. We cannot say alphabets or letters because we can have many times special characters. Now, full stop, comma, semicolon, hyphen, dash, question mark, exclamation mark, all these are basically what? They are also letters only. And there can be multiple types of other alphanumeric characters. So what we do? We simply use the term symbol. That's all. So remember this way, a message will contain symbols, symbols will contain bits. That's all. A message hello is containing symbols and symbol is containing binary digits or bits. Symbols are always discrete. That means message will contain H-E-L-L-O. After H-E comes, L comes, L comes, O comes. That means symbols are discrete, symbols are not continuous. Now each discrete symbol is represented by a ASCII code, then that is becoming a binary information. So whenever we say bits or binary digits, we have large amount of bits. We nowadays deal with gigabits per second. Earlier we had kilobits per second, later on we had megabits per second. Now we are dealing with the gigabits per second. Also we are dealing with terabits per second. So those many binary information are there. Binary information always contains these symbols, and symbols are in turn comprising of a message. Remember this? In the next class, we will continue. Until then, take care and bye-bye.